Hello, hello, hello. What ho? Welcome back to another exciting adventure of the Plain Truth. I'm your host, Travis Finley. This is going to be another interaction with the Open AI chat. Um, I wanted to just continue to see if anything new comes up and delve into other aspects that I haven't necessarily asked before. I can't remember what is a mirage. I think I asked the first time or whatever, but now I put in the request explain the conditions necessary for a mirage. And this is the response. A mirage is a fascinating optical phenomenon that occurs due to the bending of light rays as they pass through air layers with varying temperatures. It typically gives the illusion of distant objects or bodies of water appearing displaced or distorted, often creating an image that seems to be shimmering or floating above the ground. The conditions necessary for a mirage to form include the following. Number one, temperature gradient. A mirage requires a significant temperature gradient, meaning there should be a rapid change in temperature with height or horizontally near the ground. This condition is typically found in hot desert regions or over sun-heated surfaces such as asphalt or sand. Now, here's my comment, or water or snow, right? So, significant, what does that mean? Rapid, how rapid? Height implies vertical, horizontal does not. So, right here, in my opinion, there's a contradiction. There should be a rapid change in temperature with height or horizontally. Oh, is that like an ex that's an either or, right? Or it's an explanatory comment. Are you hungry or just munchy, right? I'm a little bit munchy or I'm hungry. It's like it's it's a nuance. But there's a difference between height and horizontal. Those are two different concepts. That's the y-axis and the z-axis. Those are two different things, in my opinion. So that was the first thing necessary. The second thing necessary, and whether or not this is compounded one on top of the other, are these all necessary, or is just one of them necessary? These are the kinds of conditions that could be, right? That's another qualification that needs to be made. But apparently, just from a straightforward reading, the conditions necessary are these five. If you don't have these five, you're not going to have a mirage. I don't know. Number two, layered air. The atmosphere needs to have distinct layers with different temperatures. These layers can form due to various factors, such as the heating of the ground, temperature inversions, or the presence of a cool air mass above warm ones. So here's a temperature. See, here's an explanatory conjunction in the word or, right? These layers can form due to temperature inversions or the presence of cool air masses above warm ones. That's a temperature inversion, right? The lower layer closest to the ground is usually hotter, while the upper layer is cooler. As far as I know, that's the way it always is. So there's no such thing as a temperature inversion. Like, when do you ever have cold air below hot air at the ground? Because that's where mirages happen. Mirages don't happen up in the sky. We're not talking about the jet streams where you might have a warm front and a cold front, or however the smurf those things happen, right? We're talking about something that is along the surface of the ground. So from my feet to the observation 6 miles away, that's horizontal. And I'm looking at 60 inches right? My eyes are at 60 inches, but as I'm looking out in front of me, my eye level is dropping down because the target in the distance is displaced by the condition of the medium. Okay? So the second thing is layered air. The first thing is temperature gradient. The third thing is total internal reflection. Now, this category, this quantification is rejected by Andrew Thomas Young. When I went into my explanation in our email about mirages and I used this term, he corrected me. So I don't think Andrew Thomas Young would accept this number 3, but here it is. When light travels from one medium to another, such as from air to water, or from air to a denser layer of air, okay, that's not change in medium, that's just change in density. It changes direction due to refraction. In the case of a mirage, light from a distant object near the horizon passes through layers of air with different temperatures. Now, I think, again, if you're looking out into the distance 6 miles away and your eyesight is at 60 inches and you're looking below that, that's your gradient, 60 inches, right? Light from distant objects near the horizon passes through layers of air with different temperatures, causing the light rays to refract and bend. If the change in temperature is gradual, well, hold on now. Number 1 says rapid change. Now it's gradual. Which is it? The light rays may curve gradually. However, if the temperature changes rapidly, the light rays can bend sharply. My question is, what does that look like in a mirage? Can you show me a sharply bending, rapid temperature gradient mirage and a gradual, slightly curving gradually mirage? Show me that. Number 4, inverted temperature gradient. In most cases, a mirage occurs when the temperature decreases with height above the ground. As far as I know, that's everywhere. That happens all the time. This inverted temperature gradient is crucial as it causes the light rays to bend upward, creating the illusion of an elevated object or water surface. Now, this is interesting because I was expecting it to say it causes the light rays to bend upwards, presenting the image lower. That's the narrative in all of these flat earth discussions on light rays bending. Light rays that bend down present the image higher. Light rays that bend up present the image lower. Here it says inverted temperature gradients cause light rays to bend upwards, creating the illusion of an elevated, not lowered. There we go. That's really interesting. This is, yeah, this is just really interesting. Okay, fifth condition, viewing angle. And this is an A plus for this one. The observer's viewing angle is vital for experiencing a mirage. Typically, mirages are observed when looking toward a distant, flat surface, such as a road or a desert plain, at a shallow angle close to the horizon. This angle of observation is important for the bending of light rays to reach the observer's eye. Okay, so that's the end of the viewing angle. Let me go back and look over that real quick. So, flat surface, okay, such as a road or a desert plain, or water or snow, right? So, we're not talking about a completely um, smooth surface because water, if it's not placid, is going to have waves and troughs, right? It's going to have undulations in the surface. And then also, as you're looking over land, it's not completely smooth. You have elevation changes, but the overall uh, trajectory of the surface is going to be flat. It's going to be straight out and ahead of you. It's if you have if you have a ground surface in front of you that is extending in front of you and then it drops down because it's like a valley or something like that, I'm just saying for instance, then you're never going to see a mirage past that demarcation. The mirage is going to happen at the end of the world, so to speak, or as it says here, at a shallow angle close to the horizon. So the mirage is going to happen in front of the horizon, so to speak. However, okay, all right. These conditions are necessary: temperature gradient, layered air, total internal reflection, inverted temperature gradient, and viewing angle. Okay? Now, here's the concluding paragraph. When these conditions align, the light rays coming from a distant object can be refracted and bent upwards, creating a virtual image that appears higher or displaced from its actual position. Interplay between temperature gradients, layering of layering of air masses, and refraction of light causes the mesmerizing phenomenon known as a mirage. This has been another exciting adventure of the Plane Truth. I'm your host, Travis Finley. Until next time.